Hi, this is Vincent here, and here is a sample video on the practical session for IPSEC VPNs. And get a console from all of them.
Okay.
Is it clear so far, Abhijit?
Yeah.
Write a console on R1. Let's also get the console for our PCs.
Mm-hmm.
All right, and PC1 we are going to give an IP of 192.168.1.say5, right, with a /24 mask, and a 192.168.1.1 as its gateway. Correct?
Yeah.
And IP of 192.168.2.5 for the second PC with a /24 mask, and a 192.168.2.1, which we are going to give it to the router as a default gateway. Right? We go to R1. We say conf interface F0/1 on the LAN interface, and we say IP address 192.168.1.1 with the class C mask. We give a no shut and confirm that we can ping our PC.
Mm-hmm.
1.5, wasn't it?
Yeah, 1.5.
All right, we're good on that side. Let's go to the interface, WAN interface F0/0. Say IP address 172.16.0.1 with the mask of 255.255.255.252. We'll skip to R2, configure the LAN interface first.
Okay.
F0/1, IP address 192.168.2.1, class C mask there.
Yeah.
192.168.2.5. Check connectivity with the PC. Good enough.
Okay.
Interface F0/0 onto the WAN interface. 192.168.16.0.2.
Okay.
Checking connectivity there. .0.1 to ping R1. Right? So
Okay.
basically now everyone is talking to everyone.
Mm-hmm.
Right? And since we need to have basic routing up and running, I'm going to just enable, say, EIGRP.
Okay.
We say no auto summary. We say network 192.168.0.0, or rather that was 1.0,
Yeah.
right? And we say network 172.16.0.0, and the mask would be a class C again, right? Since they're using 0.0, yeah. So we'll be using 0.0.0.255 there.
Yeah.
Let's, oh, I made a mistake here. We are on R2, so this has to be 2. Remember, it's on the side.
Oh, yeah.
So I'll have to change that. No. And that we would change to 2.0. Right? Let's go to R1. Router EIGRP100, right? And we say no auto summary. We say network 192.168.1.0, 0.0.0.255. And we say network 172.16.0.0, 0.0.0.255. Actually, it would have been 0.0.0.3 there, but it doesn't make a difference. I am just letting him go with the class C. Right?
Okay.
So anyway, neighborship seems to have come up. Bottom line is we need to be able to ping from this PC to the PC2, correct? So we say ping 192.168.2.5, and after the couple of ARP drops, we have basic connectivity, right?
Yeah.
Good enough. So now let's go back to R1, start on our IPSEC configuration. Okay, first thing to do, crypto,
First thing is crypto, IPSEC MP policy file.
Policy, any number basically, right? And then we start with the haggles. So hash, options are MD5 and SHA. I'll go with MD5. A for authentication or the haggle A.
Okay.
We're going to go with pre-share because we're going to give a password. G for the group. And options on this older version is 1, 2, and 5. Right? So I'll go with 5 on this one. Lifetime, I'm going to leave it to be the default. And we are going to go with the encryption now. Right?
Yeah.
Options are AES, triple DES, and DES. I'm going to go with AES 128, which is the default. Right? So I'm going to come out. And we're going to verify what have we done so far. So show run pipe section crypto. Show do show run. Right? And we have the IPSEC policy built here.
Yeah.
Correct? So let's go and build the password, the key there. Since we have dimension pre-share, we need to have the key defined, right? So we're going to say crypto IPSEC key, right? Unencrypted password, we're going to use Cisco 123, right? And we're going to say address, and that is the peer address we need to give. So I'm going to leave it to the 0.0.0.0.
Okay.
All right. So that takes care of the phase 1 configuration. Right?
Yeah.
Okay. Now let's start off with the phase 2. We'll start with the crypto ACL. We say access list 100, say permit IP, right? And I'm going to go with the source of 192.168.1.0.
It's a 1.0.
We are on R1, right?
Okay, yeah.
So
R1,
this
yeah.
PC1 network happens to be our source network, right? And we say 0.0.0.255 because it wants a wildcard mask. And a destination of 192.168.2.0 with a similar wildcard mask.
Wildcard. Okay.
All right. Once that is done, let's go into the transform set. So we're going to say crypto IPSEC transform set. Give it a name. I'll call it TR set.
Yeah.
Right? And then we say what is our encryption algorithm. We'll say we'll use ESP, AES, but with the 256 key this time.
256 key. Yeah.
Of course, you have the option of using 128, 192, or 256. Or instead of, right? So there are options there. So I'm going to go with the highest that is available on this model. So it's 256. Then we have to define the hashing algorithm for phase 2. So we say ESP SHA HMAC.
Okay.
Right? That being done, we're going to go and define the crypto map. We're going to tie all these little pieces together with the phase 1, phase 2, and put it together so that we can apply it to an interface. Right?
Okay.
So we say crypto map, and we need to give it a name. For example, let's say CR map. That's the name I like to give. Right? Give it a sequence number there, and we have to specify that it is a IPSEC ISEC. Right? Then we put all the pieces together. We say set peer, and what is our peer address here? 172.
16.0.
Correct. R2's LAN interface address.
Yeah.
So that is done. Now let's say set. We put in the transform set for that.
Mhm.
So basically what it means here is that you can create multiple transform sets, right? And for
Okay.
each different pair, you can have a different transform set if you want.
Okay.
You understand that? Because
Yeah.
now here we are only defining for this pair, we are going to use this.
Yeah.
So I could create another map, have a different set of rules here, right?
Uh-huh.
And I could use different settings for each different location maybe.
Okay.
Maybe the router at say branch 2 is an older model and it's not going to be able to support say AES for example, right?
Mm-hmm.
Then we create a transform set with a triple test option there, right? So and maybe a lower Diffie-Hellman group.
Okay.
This is possible, right? So here we are going
Yeah.
to say use the transform set, DR set which we created. We are also going to say match address,
Match address.
the ACL which we created.
Yeah.
Done. And that takes care of our basic configuration. Let's go confirm. Show byte section
And then
crypto. Done. That is our configuration minus the access list. So I'm going to say show run pipe include access list. Done.
Yeah.
So I'm going to basically copy this out since we are not making any changes there. I'm just copying the same configuration to the other router.
Mm-hmm.
They need to match, right? So the best
Yeah.
option is basically to copy them.
Okay.
And key, we are going to say the same because we have put 0 here. Anyone can come with the same key and go for a match there.
Yeah.
We are going to create a transform set which is basically exactly the same on both sides, and it has to match of course, because if you give two different encryption algorithms to two pairs, obviously they are not going to be able to talk to each other, right?
Yeah.
And then we can define the crypto map here. Only thing is that in crypto map there will be a difference because the peer address is going to change.
Peer address will change. Yeah.
Right? But that can be the same there. And the last two values can be the same. So I'm going to copy those two values out there and then I'm going to say set peer 172.16.0.1.
Yeah.
Right? That about takes care of our configuration except for the crypto access list,
Okay.
which we are again going to copy down here. Right? So that should have basically taken care of it, and all that is left to do is now apply it. Before we apply it, let's start a capture to confirm that.
Okay.
Because the whole proof of the thing is that we should not be able to see unencrypted packets going from the site to site, right?
Yeah.
Okay, we are seeing some EIGRP traffic, right? Hello and replies going through. Now let's go to PC1 and try a ping, repeat the ping.
Okay.
Right? We are good.
Did we implement on this on the interface?
No, we did not. What I was trying to show you was that we are able to see the traffic right now as clear text.
Yeah.
Right? It clearly tells us it's then a protocol used is ICMP, and you can see inside the packet, right? ICMP ping reply, right?
Yeah.
This means that we have got visibility into the packet now with a sniffer program, right?
Okay.
Now we go out here and we go to conf.t, we go to the interface F0/0 and we say crypto map CR map.
Okay.
Done. We have applied it on this side. We're going to go apply it on this side now. Crypto map CR map.
Okay.
All right. Now things should not be so clear. We should not be able to have that much visibility there. Let's see if the things are happening now. So you already see that IPSEC traffic are passing through, right?
Yeah.
But there seems to be something wrong with it. It does not seem to be pinging. IPSEC is coming up, but we don't see an IPSEC formation happening there. So there seems to be some problem with the configuration we have done so far. Let's go check.
We did not change 1 to 2, I guess.
What 1 to 2?
On,
Oh,
like
our access list, I think I made a mistake in that one, right? I copied the access list.
Yeah.
Right? Access list should have changed. Yeah. This should be 2 and the other one should be 1, right?
1. Yes.
Right. Okay. You're correct there. Good, you notice that. So let's go and say no to this guy. And let's change this to 1 and that to 2, right? That should hopefully take care of the problem. So let's go and generate some more interesting traffic and see what happens. Yes, and we are beginning to see the encrypted security payload here.
Yeah.
Right? We are no longer seeing ICMP traffic going through.
Yeah.
Right? And for verification, we could of course go here and say show crypto IPSEC SA. That is the security association between these two. So now here says that from the source router of 0.1 to the source destination router of 0.2, we have got an active phase 1 tunnel.
Okay.
Right? And quick mode idle means that quick mode is basically used by IPSEC, the phase 2. So it says I have done my tunneling, my control tunnel is up, now I pass control to the phase 2. Right?
Okay.
So phase 2 can be checked with saying show crypto IPSEC SA, right? And it should be showing you that there is an inbound ESP SAS formed and there is an outbound ESP SAS formed, and both are active, which means, remember, phase 2 is 2 tunnels. One is for incoming and one is for outgoing traffic, right?
Yeah. Yeah.
That is the inbound tunnel which we are seeing here, right? And that is the outbound tunnel we are seeing here.
Okay.
And it says here that 9 packets were encapsulated, 9 packets were encrypted, right? And that is the hash we are digesting is the hash, right?
Okay.
So when the reply came, it says, okay, I decapsulate, because when I send it, I encapsulate it, right? For ESP, I encapsulate it. Meaning, when I'm using IPSEC, I'm putting this the whole thing in another encrypted packet, right? My original data packet should be encrypted into another one, right? So that is what we talk about encapsulation. We're taking a IPSEC packet and putting our data packet into that, right? So that's why it says I encapsulated and sent 9 packets, right? I also encrypted them and I ran the hash on that one. And when the ping went there and the replies came back, of course, the other router is going to encrypt and send it to me, right? So when this reply came back, I decapsulated, right? I opened them up, I decrypted the same, and I verified that the hashes were not tampered with, right? So those are the 2 commands to verify that. There's a command to see a bigger picture of this. That would be show crypto engine connections active, right? That clearly shows that on IKE we have 1 tunnel, which is using MD5 and AES, right? Then I see 2 IPSEC tunnels, right? Because there are always 2 IPSEC tunnels, right? Phase 2, outbound and inbound.
Yeah.
Right. So here we are talking about the outbound and the inbound.
Yes.
So here again you can see which one is which one, because we say I encrypted and decrypted. That means this is the outgoing tunnel and that is the incoming tunnel, because that's the decryption happening there.
Yeah.
Here?
Yeah.
If you want to look at, take a look at the configuration there, we say show run pipe section crypto. And we also say show run pipe include access list. Right? That is the entire configuration that you require for a basic IPSEC tunnel to come up.
IPSEC. Okay.
That's it.
Okay.
Slightly clearer?
Yeah.
All right. Did you try this thing?
I did not try this thing. That is the problem. If I tried, I would have.
Correct. This is
From
what I keep
2 days
telling you. When you
training.
see a new concept, try to, do a practical as soon as possible. Before that, concept goes out of your mind, right? So
Yeah.
once you try it out once on a practical this thing, then it stays in your mind.
Yeah. I'll do it today.
Yeah.